Okay, let's we talk about the last lecture. We talk about the bisection method to solve nonlinear equation, and we explain the theory and we follow this steps to solve our problems. It was to find XR and to check multiplication if it is less than 0 or more than 0, what we do, and repeating until we get the suitable or the interception point. And we made like this table and just follow these steps to solve problems. Now today we have another technique. In solving a nonlinear equation. This is named a Newton method, Newton-Raphson or Newton method. Also, it is used to solving nonlinear equation. Let's view. Yes. Okay. What's the technique of a Newton-Raphson method? This figure, I will explain it in another whiteboard to explain the theory, and then we will take example. Let's explain here. Okay, what's Newton say? If we have function like this, for example, this is f of x. This is function. Now, what we have here interception point. Okay, are you with me, students?
Yeah, we are with you, teacher.
Okay. We need, or we want, really, we want to find interception point. Which one? This. Okay. Let's we say x. Let's we say x I, for example, or xr required xr. Now, if we have really Newton methods, it's open method. Why? Because we need just 1 point. We need just 1 point, not like bisection method. In bisection, we need period from x1 to x2. For example, from 0 to 3 or something like this. For this named bracketing method. But in Newton-Raphson, we just need 1 point. Okay, let's continue. If we have x naught equal A, for example. We say here is x naught. This is x naught. Now, if we find if f of x naught, we will get something named y naught. What I mean, if we put x naught in function, we will get, we make it good. This is not good. Okay, we take rule. Now we will get what? If we substitute this x on function, we will get what? F of x naught. This. Now, we take something named what? Named the slope at this point. At this point, slope touched the function. The slope like this. Suppose touch the curve on this point. Now what Newton's did, he tried to find this point. This point is named x1. Then again, look at me. He will find. He will find what? F of x1. F of x1. Are you with me?
Yes.
Student.
Yes, doctor, yes.
Good. Again, he will find the slope. Now, will be x3. Look at this point, x1, x3. It is converse to what? It's converse to xr. It's converse to what? To xr. Maybe if you take 3 or 4 points or 5, you will find the xr directly. Now, we take the function. We take the function he used or the technique. We go back to the first triangle. Look at this. What he say? What's Newton say? Look at this triangle. Look. We take the where is the triangle? Where is? Don't have. What's this? No. It's like this. Sorry. We say what? Sorry. Okay. let's we take this triangle. Something like this. Okay. What is this point? Now tell me, what is this point? What is this point, student? From this triangle. This
X naught.
X naught, good. This, I'm talking about this triangle, this. Okay? I'm talking about this. This is X naught. Okay. X naught, it's mean. Okay, let's we explain this again another time. Okay, what's this point?
Fx naught.
Good. F X naught. What is this point?
X1?
X1.
No, this. It's
XL.
X1. It's X1 or Xi plus 1. This is a new X. Yes? This is new X. We have this in problem. And this is the new. Let's rename it X1. Now, if we take this this angle, let's rename it theta. Let's rename it theta. Okay, this is. If we say tan theta equal what? Who tell me? Opposite. Over what? Adjust. Is that true?
Yeah.
Yes.
Good. Now, what's the value of this? What is the value of opposite line? This. It is what? F of X naught. This is F of X naught from here to here. From here to here. It's look like Y. Y of X naught. Are you understand?
Can you repeat that, please?
What I mean in opposite line, this is
It's Fx naught.
the length of this.
X1.
The length of this line is equal to what? F of X naught. It's clear.
Yes.
But let's you with me. Let's you with me. I have this function. Let's we say f of x equal x squared minus x, for example, minus 10, for example. Now, if I have this point equal x naught, let's equal 3 or 5. Now, what's the y? as you know, every x have what? Have y. Every x have y. Now, if we say f of x naught, I mean f of
Equal 10.
5, what? 25 minus 5 minus 10, it will be
Equal
what?
10.
It will be 10. That's mean this is 10. That's mean again, the length of this line is what? It's 10. Okay? طلاب, students. It is clear?
Yeah.
Okay? Then this line of this triangle is equal f of x naught. Let's we delete this. Let's we cut. Okay. Now, who tell me adjacent line this length equal to what? Who tell me? From here to here. This length of this line equal what?
X naught minus x1
X naught
minus x1.
minus x1. That's true. Why? Why? Because if we say this equal, for example, 5, and this equal 4, that's mean the distance from x1 to x2 equal what? 5 minus 4 equal 1.
1.
Okay? Now, this is equal tan theta. Now, what's tan theta mean? What's tan theta mean? Tan theta mean, it's mean the slope of hypotenuse. This is the hypotenuse. هذا الوتر. This is hypotenuse. This in which color? Let's we say this color. This. Tan theta, it's mean the slope of this line. Okay. How could I calculate the slope of this line? The slope of this line. This. We have rules say, look, f of x equal the slope of tangent at any point. Then if I say f dash x naught, I mean my x naught, this x naught, equal the slope, it's equal to the slope of tangent at x naught. Where is the tangent? This is the tangent. This is the tangent at x naught. If we say we have like this, and we have any point here, for example, this point, the tangent, line tangent, this point, to find the slope of this line, it's equal f dash x. Which fx? Fx of the what? Of the function, this function of this figure. If we take the derivative and put this point, we put this point, for example, x naught, we will get the slope of the tangent. Slope. You know, this is slope equals 0 because it is like x-axis. Okay? The slope of x-axis equals 0. Slope equals 0. And if we raise this like this, if we raise it, slope will increase. It will be, for example, 0.5. And this slope of this line is, for example, it's 1. This is when we have 45. When we have angles 45, the slope will be 1. If we rise it, it will be 1.2. Here 1.7, for example, and here 2. Even I have vertical line, and then I don't have, it will be finite. It's undefined. Finite for the vertical. For y-axis, we have no slope, or it is infinity. It will be infinity because we will divide to 0. Divide to 0. Why? Because if I have like this triangle and this line moved, it will be like this. Delta x will be 0, then delta y will be divided to delta x. It will be delta y over 0. Everything divided to 0, it will be what? Sorry, it will be infinity. Now, from the slope equation, finally I will change this to f dash x. F dash what? X naught. This will be the slope. Now, the final equation will be f dash x naught equal what we have. Let's see, f of x naught. Sorry, f of x naught over x1 minus x naught. Now, what I want, it is x1. Let's rearrange this. It will be x1 minus x naught equal f of x naught over f dash x naught. Arrange again for x1. It will be x1 equal It will be
fx naught per f dash x naught plus x naught.
yes. Just a minute. X. Sorry, this is will be x naught. I wrote x naught minus x1. Yes. No, x naught minus x1. X naught, yes, minus x1, it's good. Then let's we change this. X naught minus x1. It will be what? If I rearrange it, if I arrange it, it will be x1. I need this x1. It will be x naught minus f of x naught over f dash of x naught. This is my function. I will use it to find x1 and again repeated to find x2. That's mean x2 will be x1 minus f of x1 over f dash x1, and so to find xr. Okay, now let's me just like this, xi plus 1, it's mean this x1 equal xi minus f of x naught or I over f dash x naught. Now we have algorithm procedure to solving Newton-Raphson or using Newton-Raphson method. The first step, it will be evaluate f dash of x, and it is easy. Then just you need initial guess of root. You have to have 1 point xi or x naught to estimate the new value of the root xi plus 1 and use this function. To find the estimated error, relative estimated or approximate error, you can use this function. It's easy. It's just x new minus x old over x new by 100. This is to make comparison if you have already E tolerance. If someone give you E and tell you make comparison between this two comparison, you need to make this procedure. If this error more than, you have to repeat or continue on your solution. If estimated error more than not more than ES, you have to stop. Let's we take a simple method and explain it in details, and I need you to share your idea, share your information with me. Let's we take this example. What's he say? He say use Newton's method to solve this. What's he mean? What's he mean? Who tell me what's he mean?
Find the x value.
Finding what?
X
Value of what? Huh?
For x.
X. What's X? What's mean X? People.
Means point.
All of you, with me. What's he say? All of you. Okay? What he say? What's he want? He says solve this equation. What's he mean? We need to find what?
Finding intersection point by finding x point.
Who are you?
I am Muhammad.
Excellent, Mohammed. Good. Excellent. Do you hear Muhammad?
Yes, doctor.
We need to find intersection point between this function with the x-axis by using a Newton method. Let's we take this copy and let's we come here. Okay. Let's we solve this step by step. Where is my function? Where is my function? This is my function. F of x equal x cubic plus x plus 1. Okay? Now, I need 1 point. He say use 2D. 2D, it's mean 2 decimal point. After point, we have to just 2 numbers. We will take just 2 numbers. Okay, we need now, what we need to solve this by Newton Raphson.
F dash.
Yes?
F dash.
Good. Let's we derivative this. Drive this. F dash x will be what?
3x power 2.
Yes,
Plus
plus
2x squared plus 1.
Good. Now, what we need, another more.
We need to choose a point. I mean,
Yes, we need points. We need x naught. Sometimes he give us, sometimes he will not give us. Now, how I could choose any point really.
you can choose 0.
Yes, we can. We can use 0. If we say, look at me, if we say x naught equals 0, let's we substitute f of 0, it will be 1. Now, let's we take x naught equal, for example, minus 1.
It will be 4.
Minus 1 is f of minus 1 equal what? Minus 1. Minus 1 plus 1. It will be what? It will be
Minus 1.
minus 1. Okay? Now, we have 2 points. Let's we take, for example, just a minute. Okay, let's we take this. What we have? what we have? We have f of f0 equal 1 and f of minus 1 equal minus 1. If you remember in bisection, if we multiply this f of 0 by f of minus 1, it will be what? It will be minus 1. That's mean less than 0. That's mean my XR or interception point between 0 and minus 1. Why? Because one of them negative and one of them positive. That is true. If we say here, if we look here, what's happened? If we say that, look at this. This is interception point, XR. If we have point below and above, that's mean the interception between them. Okay? As what? As we mentioned here. What he say? Here. This can be checked. What check? Check lower XL, upper XL guess for the rules such that the function change sign over the interval. The function sign must be changed, must be 1 minus and must be 1 positive and 1 negative. Now let's we take this x naught equal 0. Okay, let's say x naught equal 0. Now it's so easy. Look at me, so easy. Just apply the rule. What's the rule? What's the law say? X I plus 1 equal xi minus f of xi over f dash xi. Now xi equal x naught. That's mean x1 equal x naught minus f of x naught over f dash f of x naught dash. It is clear?
Yes.
This is our equation. We need to find what? The new x. The new x equal this is old x, and this is the function of old x over derivative or of function x old. Now x1 equal x naught what? 0 minus f of x naught
1.
Now let's we find f dash x naught. It's mean f dash of 0 equal what?
Also, it is 1.
Also,
Equal 3 by 0 square plus 1. That's mean equal what? 1. That means x1 equal 0 minus 1, then equal what? Minus 1. This is x1. Now, x2 equal what? Who tell me? Who tell me? Student, we find x1. It's equal what? Minus 1. Now we need to find what? x2.
X2.
Like this. Equal what?
Equal X1.
Minus 1.
No. Let's we write the equation first.
It will be X1 minus Fx1.
x1, yes, good, minus f
Fx1
of x1 over f
dash
of
X1.
x1 dash. It's easy. It is easy. Now, x1 equal what? Minus 1 minus f of x1. Let's we find f of x1. That's mean f of minus 1. We have already. It's minus 1. What about f dash x1? It's equal
4.
f dash minus 1. It will be what?
4.
It will be 3 by minus 1 square plus 1. It will be what? It will be 4. Good. We have here minus 1 over 4. Now, it will be minus 1 minus, sorry, it will be plus 0.2, 1 over 4.25. It will be minus 0.75. This is what? x2. Now x3. Let's we change the color. x3 equal what? x2 minus what? Student.
f of x2 per
x2 over
uh,
f of x2 dash.
prime dash.
Now, x3 will be x2 what? Minus 0.75 minus, let's we find f of x2. It will be f of, minus 7, minus 0.75, it's equal minus 0.75 cube plus minus 0.75 plus 1. Let's we calculate this. If I write this, I can't calculate. Right, it's good. Then I will put f. Let's we say minus 0.75 cube minus 0.75 plus 1. No, fixed it. What's no? It will be point Yes. What? Who can help us?
minus 0.70.
Yes. Evaluate. This will be what? That's true. 0.25 minus. I think that yes, it will be 0.2. Sorry, 0.25 over. Let's calculate f dash of minus 0.75. It will be 3 minus 0.75 square plus 1. It will be what? It will be what? Let's write it.
It will be 2.68.
2 point what?
68.
68. Like this?
Yes.
Let's check. Thank you. Plus 1. Let's me check to solve it. Three points. Good. It's 1. How? Is that true? Let's use calculator. What we have 0.75 by 0.75 equal by 3 plus 1 equal what? What's this number? Point 0.75 by 0.75, yes, by 3 plus 1 equal, yes, good. Thank you. It will be what? What you say?
That is 2.687.
Oh, yes. Thank you. 2.68. That's mean x3 equal minus 0.75 minus. Let's divide this. Let's take inverse this and multiply by what? 0.25 by 0.25. It's equal 0.09
0.09 class.
3 صح. It's 0.093. Now let's sum this. Sum this, please. It will be minus
0.656.
65.
656.
Let's 66. Okay. Now we huh?
But Doctor,
Because it is minus.
no, it's same. Minus, it will be higher.
It will
Yes,
be
you have to
0.84.
You have to sum this because the same sign.
It will be minus
84.
0.84.
Huh.
Yes.
84.
Yes. 0.84.
0.84 class 3.
Let's okay. Okay. And we will continue to solve this, but the question is when we will stop. When we will stop. Let's go back. I will delete this, just this. Now, what we have x1, oh sorry, x0, x1, x2, x3. Now, to estimate the error, EA is equal what? First error should be x1 minus x0 over x1 by 100. Oh, x1 equal what? 0. x0, x1 minus 1, x2 minus 0.75, and this minus 0.84. Let's calculate the first error. It will be minus 1 minus 0 over minus 1 by 100. It will be 100%. This is the first error. Okay. The second error, this is first error. The second error between them, so EA2, it will be x2 minus x1 over x2 by 100. It will be what? It will be minus 0.75 minus, it will be plus 1 over minus 0.75 by 100. It will be plus. It will be 0.25 over 0.75 by 100. How much? Don't care about the sign because we have absolute.
33.3.
33.3 percent. This is EA2. What's about EA3? EA3 will be minus 0.84 plus 0.75 over 0.84 by 100. It will be what? Oh, here will be, it will be 0.09 over 0.84 by 100. It will be what? Who with me?
10.7.
10.7. It will be
Yes.
10.7%. Look at the error. We have 100 and then we have 33.3, and then we have 10.7. It is degrees, that is good. Every time error degrees, that's good indication. That's good indication. And if we continue, it will be more small, and then will we finish. Then, for example, I will told you an exam, solve equation till you have, or till you get error less than 50%. 10%. That's mean if I say that, what's error you have? 10. It is less than 15. You can stop. If I say E must less than 10%, then you need to make another iteration. You have to find x4, for example. Maybe you need to find x5. Is that clear? Sorry.
Yes.
Now let's read.
Teacher.
Let's read back. Now look here. What he find, or what he did here. He take 0.5. He take 0.5 as x0 or x1. Same. x1 0.5. He choose this. And then he find x2 and x3 and x4. If you look, x3 equal to what? To x4. That's mean no change in x. That's mean this is our interception point, because error here will be what? Will be 0, because if we say EA equal minus 0.68 plus 0.68 over minus 0.68, it will be 0 over 0.68 by 100. It will be 0%. That means we don't have any error. That means this is our X required interception point. Okay?
Okay.
Let's see. Where is this? This is. Let's solve this. Let's solve this in MATLAB. I will show you. If we say we have P equal, I will explain this, but now we just find the roots of this. By the way, in this equation, how many roots should I have? Must I have? How many roots for this
3.
equation? Yes.
3.
I must have 3, because this is third degree. But as I said, in numerical methods, usually we find one root. Let's we solve this. What we have? I have 1 and I have 0 and I have 1 and I have what? I have also 1. I think that. Okay, this is B. Let's we find roots E. Look, what he give us? What he give us? Look at this. He give us 3 numbers. This is 3 numbers. Let's look at this. It is minus 6.8. Where is the solution? Minus 0.68 plus 0i. This is he give us like a complex number, and this is 0. That's mean just this, and the others. This is 2. This is 2 roots. Another 2 roots. Okay. It's so easy to find roots for polynomial in MATLAB. Let's we come back. This is another example. Try to solve it by yourself. I solve it, but try to solve by yourself. Okay. Now let's we talk about the advantage and drawback or disadvantage of the Newton-Raphson methods. What advantage of this method? Who read? Ibrahim, Khalil. Ibrahim,
Yes, doctor. Yes, doctor.
read this, please.
Advantage converges fast. Quadratic
Quadratic
convergence.
convergence.
If it converges.
Converges. What does that
Second,
mean?
it requires only one Jesus.
Just a minute, please, Ibrahim. Just a minute. What that's mean? Converges fast. That's mean we find solution by the less than as less than as steps. Sorry. I.e., maybe by 3 or 4 or 5 steps, we can find the results, and it is go to the solution fast. Are you understand? That's mean converge. That's mean converge. It's be near to the solution quickly. It's quickly find the XR. Okay. When we say diverge, that's mean no, it's go away. It's go so far from the exact solution. Continue, Brian.
Yes, doctor. Second, requires only one guess.
What does mean?
Sorry, doctor, I don't know.
It's need what? You just want to start.
You can choose 1 point.
That means
1 point,
Only
just
one
X
guess.
naught. Which method need 2 points or interval? Which one?
Our
Bisection method needs what?
period.
Interval. Yes. Okay, this is the advantage of this one. What's the disadvantage? Drawbacks. Let's we choose someone to read. For example, Safin.
Yes, doctor.
Safin. Where is Safin? Are you there, Safin?
Yes, doctor.
Good. Help me to read this. Divergence.
Divergence at inflection point is selection of the initial guess or an iteration value of the root that is close to the inflection point of the function f of x may start diverging away from the root in their Newton-Raphson method. For example, to find the root of the equation f of x equal to x minus 1 by 3 plus 0.512 equal to 0. The Newton-Raphson method reduces to xi plus 1 equal to xi minus xi by 3 minus 1 all by 3 plus 0.512 divided by 3 multiply xi minus 1 by 2. Table 1 shows the entreated values of the root of the equation. The root starts to diverge at iteration 6. Diverge at iteration 6 because the previous estimate of 0.92 is close to the inflection point of x equal to 1. Eventually, after 12 more iterations, the root converges to the exact value of x equal to.
What he's saying, look, I will explain on the figure. What he say here. If we have like this function, we have inflection here. Inflection here in this curve. Look, if we start with 5, x naught 5, this is this is 5. If we start here, look, it's firstly it's converge. This is our point. This is our interception point. But if we have function like this and we have inflection here, this is inflection point. When he be close to 1, this is 1, it's near to 1. He is diverge. Let's go to what? What we get? What we get? Minus 30. So far. It's something here. Then he will converge again, and we need what? We need 18 iteration. We need 18 iteration to find the interception point. Then this is one of disadvantage of the Newton-Raphson method when we have an inflection point. This is one of the disadvantage of the Newton-Raphson method. Again, another one. Yusra.
نعم.
Yusra, was there another disadvantage or drawbacks of this method. What's he say? Division by what?
Division by 0. For the
Division.
equation,
For example, if we have this equation, then
fx
you know we need to find what? What's this? This is f dash x. Okay?
okay.
If we substitute x naught equal 0.02, then what we will get
The
in
f dash
denominator, we will get what? 0. We will get 0. As you know, we could not divide by what? Could not divide by 0. Any number to 0.
It will be infinity.
have no solution.
Will
Any
be no solution. Yes. Then in Newton-Raphson method, if we have f dash x equals 0, we cannot solve the equation. Okay? This is all what we have in Newton-Raphson. You need to solve this equation. For example, sorry. Just a minute. And you have to solve this. And let's put plan for the next week. Are you hear me? All of you?
Yeah, teacher, I'm aware.
Okay. Next week, inshallah, at university, at class, in your class, we will in first 30 minutes we will make exam just for 30 minutes. Then in two subjects, in bisection method and Newton, you have to read carefully and hard. Then we will what? After that, we will take a half hour, 30 minutes again to explain or to take let me show you. Sorry, not here. We will take inshallah we'll take introduction to MATLAB in your class. I will explain something in general. Then we will go to the lab. Do you have? You have laboratory, okay? Computer laboratory.
Yeah, we have, teacher.
Okay. Please, Shihab or anyone, if you could check if they have MATLAB on their computers.
Okay, I will check it tomorrow.
Please. Then we need to apply something. I need you to learn more because MATLAB is very useful for you, for all engineers. What's we have We will take introduction. We will try to solve some equation. We try to solve some equation to find roots like this we did today. We will use some function like f0 and like roots. This is commands used in MATLAB. And what we have also, this is f0. We have also VBA solve, or we have also we have solver. I don't know if we, yes, we have solve and VBA solve. We have two functions. We will see, you will see it's very easy to find roots by use MATLAB, and it is fast. Then in next lectures we will try to learn programming. If we have time, I will learn you the programming in MATLAB by use many commands like for and while and many commands. Okay, I'm finished. If you have any question you could ask, please, if you have.
No, Doctor, thank you.
Okay.